Alrighty, hey guys. Today we're just gonna finish up the notes of slope fields that we started on Thursday of last week. So this is starting on page 615 in your notes. And this is actually referring to page 615 and page 614. So if you look at 614, you're matching a slope field to a differential equation. So since the slope field represents all of the particular solutions to a differential equation, and the solution represents the antiderivative of a differential equation, then the slope field should take the shape of the antiderivative of dy dx. Okay, so the easiest way to solve these is to find the original equation, so take the antiderivative, and then look at the graphs and the shape that these slope fields make and see if you can match one. Okay, so here we're looking at dy dx is equal to sine x. Okay, and so if we do separation of variables, so where we have dy is going to equal sine x dx, and then integrate, you should get y is equal to negative cosine x plus c. Okay, so if you know what the graph of cosine looks like, it's the one that starts at 1. I call it a salad bowl because it looks like a salad bowl. Okay, it looks like that. So negative cosine is going to start down here and go like that. Okay, so if you look at your options of slope fields on page 614, you can kind of narrow down some options. Okay, so on the next slide here we have two options, either D or I. Okay, and so if you're not sure which one of these to pick, always try a test point. Okay, and so a good test point would be 0, 1. So if I make a table here of x, y, and then dy dx, if I look at the point 0, 1, okay, and I plug those values into dy dx, well, sine of 0 is still 0, okay? So at the point 0, 1, you should have a slope of 0, okay? So if I look at D right here, does that have a slope of 0? No. Okay, if I look at I as 0, 1, do I have a slope of 0? Yeah. So I is the 1. Okay. Okay, if we look at number 2, it's dy dx is equal to 2x plus 4. Okay, and again, we can kind of see the shape of the slope field by taking the antiderivative. Okay, so dy is going to equal 2x plus 4 dx. And then we integrate. So you should get y is equal to x squared plus 4x plus c. Okay? And so if you look at all of your options, you should have 3 options that look like this graph. This graph makes a parabola. Okay? So we have 3 options, A, F, and G. Okay, so my original was x squared plus 4x plus c. Okay, now I'm going to rule out G right away, because if it was G, then this would have to be a negative x squared. Okay, so G's not working. So now we need to pick between A and F. Well, again, use a test point. Okay, so if I make a table here, again, of x, y, dy dx, okay, we're going to plug in 0, 1 into dy dx. Okay, so 0, 1, what is that, 4? Okay, so at 0, 1, does the graph have a slope of 4? So if I look at A, yeah, it looks pretty steep. Would I say it's 4? I don't know. But if I look at F at 0, 1, is that 4? No. So your answer is A. Okay. Alrighty, number 3. So we have dy dx is equal to e to the x. Now, if you take the derivative of e to the x, okay, if you take the derivative of that, it's just e to the x plus c. Not plus c, we're taking derivatives. It's just e to the x. Okay, so if you take the antiderivative of e to the x, you're going to get e to the x, right? So dy is going to equal e to the x dx, integrate, y is equal to e to the x plus c. Okay, so we have two choices here, either b or e. Now, if you know what the graph of e to the x looks like, it's an exponential function, okay, and it's going to look something like that. Well, that is closely represented by b, okay? E doesn't really have that shape. There's some issues going on at 0 with e, okay? And if you really wanted to make sure, again, plug in a test point. Okay, 0, 1. If I plug in 0 for x, I get 1 out. And so at that point, you should have a slope of 1 there. Okay? Okay, so I did the first 3. If you guys want to pause the video here and see if you can finish out the rest of those, and then I'll have the answers on the next slide. So these are the answers to page 615. Okay, if you're not sure about anything, you can always ask me in class. Okay, so let's go on. Now we're looking at page, 616. Okay, so it says match a slope field to a solution to a differential equation. So when given a slope field and a solution to a differential equation, then the slope field should look like the solution, or y. Okay, so before we were given dy dx and we had to find the slope field. Here we're given y, which is actually a whole lot easier. Okay, so if you look at number 1, it's just y equals x. Okay, so I want to find the slope of this, so I need to take the derivative. So dy dx, well, the derivative of x is just 1. Okay, so what this means is that every point, either x or y, the slope field will have a slope of 1. So if you look on the page before, you should see that C is the only one that has a slope of 1, okay, at every single point. Now, think about it in the y. So y equals x. The slope field should look like the solution or y. Well, y equals x, that's just a straight line. Does the slope field look like that? Yeah. Okay, so you know for sure that's the one. Let's go to number 2. So y equals x squared. Okay, well, what does this look like? It looks like a parabola. So if you take the derivative with respect to x, you get 2x. Okay, now if you wanted to use a test point, you could. Okay, if you plug in 0, 1 into dy dx, what are you going to get out? Well, you should get out 0. So at 0, 1 on your graph here, do you have a slope of 0? Yeah, so A is the one. Okay, so go ahead and take the derivative of each of these and then see if you can match to the slope fields. Okay, and on the next slide is the answers. So these are the answers. If you have questions, you can let me know in class. Okay. Okay, moving on. This is on page 618. Okay. So I think this is part of an AP question. I've just modified it a little bit. So shown below is a slope field for which of the following differential equations. Explain your reasoning for each of the choices below. Okay, so those of you that were in class on Thursday and Friday, or on Friday at least, we did go over this one, but I didn't get to really explain. So I'm going to do that here. So if you look at this slope field, you need to figure out, okay, which one is going to be a good test point? okay? It all depends on the slope field. Sometimes it could be 0, 1, 0, 0. It doesn't matter. The things that I look for is where's the slope 0? Well, on this particular slope field, it's 0 all right here and all right here. So any of those points will do just fine. Okay, so let's choose the point negative 1, 1. So you're going to plug in these points into each of these differential equations and see which one works. So if I plug in negative 1, 1 into A, well, that's negative 1 times 1, which is negative 1. Well, at that point, I need a slope of 0. So that's not it. If you look at B, negative 1 times 1 minus 1, so that's negative 1 minus 1, which is negative 2. That one doesn't work either. Okay, look at C. We have negative 1 times 1 plus 1. So that's negative 1 plus 1, which is 0. So that's a possibility. Okay. If we look at D, we would have negative 1 times 1 plus negative 1. So it's negative 1 minus 1. Again, that one doesn't work. And let's look at E. So we have negative 1 plus 1 cubed. Well, that's 0 as well. So either of those would do it. Okay? Now, which one is it? Let's find another test point to see which one really works. Okay? So I don't want to do a 0, 1 again where the slope is 0. I want to try something a little bit different. So I'm going to choose the point right there. That looks like a slope of 1. So we're going to see how it goes. So that is the point 0, 1. So if I plug in 0, 1 in for C, I get 0 times 1 plus 1, which is 1. Okay. So if I plug it in for E, 0 times 1, 0, 1, 0 plus 1 cubed, which is 1 cubed, which is 1. So both of those work out. Well, that didn't work. Okay. Let's try another point. Let's try this one here. Okay, it's kind of an odd one. I think that's negative 3, negative 1. Okay, and that looks like a slope of positive 1. Okay, so if I plug it into C, I get negative 3 times negative 1 minus 1. So negative 3 times negative 1, that is positive 3 minus 1 is 2, positive 2. Okay, if I plug it in for E, I get negative 3 plus 1 cubed, so that's negative 2 cubed, which is negative 8. Okay, that is definitely not a slope of negative 8. Okay, so the answer is actually C. Okay, E does not work. Okay, so if you have to choose more than one test point, do so. Okay, it can kind of get time consuming, but it'll be worth it on the AP exam. Okay, so dropping down to the last problem, I believe this was a type of AP question. I've seen kind of a lot of these, sketch the slope field, sketch a solution curve, all that good stuff. Okay, so consider the differential equation dy dx is equal to x over y to answer the following questions. So A, on the axis below, sketch a slope field for the equation. So I'm going to let you guys do this, pause the video, and then check your answer with mine. Alrighty, so your slope field should look something like that. As I said in class, do not draw a vertical line where the slope is undefined. Okay, so anytime where y equals 0, anywhere along this axis here, do not draw a vertical line because a reader will grade that wrong. Okay, now it's always a good idea to make a table. Yes, you guys can do this in your head, but if you make a table and draw like these triangles here, that kind of gives the AP reader an idea of what you were trying to go for, especially if you have really sloppy handwriting like mine, okay, and can't quite get the angles right, okay? Or you could even draw those triangles, well, I don't know that you would draw them on the slope field themselves, okay? But that's the reason why I always make a table, is so that someone knows kind of where my thinking was going, okay? So part B, it says sketch a solution curve that passes through the point 0, -1, okay? So if I look on this slope field at 0, -1, I'm starting right, if it would make a dot, that would be awesome, right about there, okay? So like I said, whenever you're sketching slope fields, try to go in between the lines there. It's not going to be exact, but just do the best you can. So my slope field is going to look, or my solution is going to look something like that, okay? Again, not perfect. But just to make sure that your little tangent lines kind of follow your graph. That's the main thing that you want, okay? And then for part C, it says find the particular solution for y = f of x to the differential equation with the initial condition f of 0 is equal to -1. Okay, so this is part C. So what we're going to do is just find the particular solution. So do our separation of variables, okay? So here I can actually cross multiply. So I will have y dy is equal to x dx, okay? And then we can integrate. Well, that will give me 1/2 y squared plus 1/2, sorry, not plus, equal to, so y squared is going to be equal to 1/2 x squared plus c, okay? So I'm trying to get y by itself, so I'm going to multiply by 2 on both sides, okay? So those go away, and 2 times c is just going to make a bigger c, okay? So y squared is going to equal x squared plus c, okay? It's still a constant. Then we're going to take the square root. Just kidding, not at this point. We want to plug in our initial condition, okay? So at this point we can find out our c. So if x equals 0 and y equals -1, so I can say that -1 squared is equal to 0 plus c. Well, that means that c is equal to 1. Okay, so my particular solution is going to be y squared is equal to x squared plus 1. Now we can take the square root. Y is going to equal plus or minus the square root of x squared plus 1. Now, you have to use the initial condition to check whether or not it's plus or minus. Okay? And so here's some food for thought for you. If your initial condition, if y is negative and you're taking the square root, you have to have a negative in front of the square root in order for that to make sense. Okay? Because you can't take the square root of a negative number. Okay? If you're not following what I'm saying, just go ahead and plug in that initial condition and see which one works, either the positive or the negative. Okay, and you're going to find out that your particular solution is y equals negative square root of x squared plus 1. Okay, so that's it for slope fields. They're pretty fun, pretty straightforward. You guys will have homework on this, and it will be due probably Monday of next week. Let me know if you have any questions.